Welcome back, everybody. No, I'm muted. No, I'm not muted. I'm not muted. Okay. So welcome back, everybody. Let's continue. Actually, this is the boring part with history and so on. So I will very soon come to the interesting parts. So subject-oriented, time variance, I already said that. So it's quite unusual that you would go more than 10 years. Back in the past, there are several reasons for that. One of the reasons might be that the data was too old or the schema changed too much, so it would be too cumbersome to do that. And also typically, I mean, I don't know if you've ever seen company reports, so the ones they have to submit and so on, but typically it goes just a few years back, not so much more than that. So 5 to 10 years. But I've heard there was continuing education students in the class a couple of years ago who shared a few insights at the companies that they were working at. And some said that they even digged data on paper, like the blueprints of the water pipes in the building and so on, that they also needed to analyze. But that was all on paper because that was coming from like a century ago. All right, but anyway, typically in OLAP, you go back 5 to 10 years. We'll see that that's what's called the dimension in OLAP, but that's very soon. The third adjective is non-volatile. It just means you don't change the data. That's it. You just read the data, but you don't modify it. That's what it means. You import the data from the other systems, and then you access it. So yeah, there's not so much to say to that. You don't modify it, you just analyze it. And finally, integrated. It means that typically, the data that you get into your business analytics software, so the data cubes, they actually come from the normal systems of the company after you imported them from where? Right, so from there. So the data comes from ERP, so that's enterprise resource planning, the HR, the finances, and so on. That's the ads. I don't know if you saw the Rockstar ad on TV and so on. So that's typically that kind of software. Then you have the CRM, that's customer relationship management. OLTP, that's all the relational database management systems where you have the day-to-day business. Maybe also files. You might have just data lying around. I shouldn't be saying that, but this is reality. That also includes Excel and CSV files that are lying around on individual computers, which is actually absolutely terrible when you have a company with 1,000 machines and it's just files spread over. But still, it's a problem that we are trying to solve, to no longer use that, because you literally have in some companies people who send who take an Excel file, print it, send it via postal mail, and then the other side, you have people who enter it back into some spreadsheets. Then you can make errors and so on, right? So ideally, it should all be in databases. But anyway, that's still one of the sources. And then you ETL it into the system. ETL means, does anybody know what it means, ETL? Extract, transform, loads. I have a slide here. I will tell you in a bit. It's a verb, actually. You know, in English, we love to turn things into verbs. So we say that we ETL the data into the data cubes. And then so I represent the raw data as wheat. And then once you ETL'd it, that's flour. And then the final report is bread, right? Just as an analogy with data. So you can analyze, you can build a fancy PDF report for the C-level executives, or you can mine the data with machine learning and so on. Now you might ask, why do we bother with all that? Why do we need to import the data and go through the effort of putting it somewhere else? Can I not just directly analyze the data where it is? Can I not just connect to PostgreSQL on the day-to-day business of the company and just query it, right? And launch my query and so on? Well, I can tell you, if you do that, within 1 hour, you're going to have people knocking at your door, complaining, what are you doing? Everything is slow, you're overloading the systems and so on. They're going to be mad at you. You cannot do that. Because the day-to-day systems, they have to work for the day-to-day business of the company. And you know that whenever you run long-standing queries, you're just using a lot of resources. That is the reason why we go through the trouble of importing it somewhere else, preferably at night or during the weekends, when the systems are not really needed. Then we import it somewhere else, and then we run the data cubes query from that somewhere else. Who is still with me? Right? Very good. Okay. And then I need to tell you ETL, extract, transform, load, very quickly. Extract means that you basically need to take it from here to here. That means that you might have the need to have systems in place that trigger, for example, every night or every weekend, data gets transferred over, right? Triggered by some update on something. You might need incremental updates, meaning that the first time you import everything and then the next times every week you only import what has changed, right? So that's complicated to do. You might need gateways between the systems, between PostgreSQL and whatever you're using for your data cubes. And who says gateways also says cybersecurity, firewalls, and so on. So it can get very complex to handle all of that. So that's the typical issues that you need a lot of experts to deal with these things, right? But you basically extract it from wherever it is, connecting the machines. That's extract. Then you have transform. Transform means that you're basically taking things that lie around in plenty of different places. They look different, right? You might have coming from CRM, from ERP, from OLTP, from the files. It's very heterogeneous, but you need to put that in data cubes. There is nothing more structured than a data cubes, as we will shortly see. So it means you need to transform the data to make it fit in the data cubes. You might need to clean up some things. You might have multiple languages. Like let's say you have a list of people and you have Mr., Mrs., Herr, Frau, Monsieur, Madame, Senior, and so on. You need to basically translate that, make it consistent, and so on. Right? It's just one of the examples. You might need to join tables together, to merge, to filter if you don't want everything, and so on. That's called transforming. Right. So transforming, you can think of the relational algebra, but so very complicated queries. That creates a billion-dollar business for consulting companies, by the way, these kind of things, because it very quickly gets very expensive. And finally, load, that's when you put it in the data cube, in the system that you're using. I'm not telling which one because I have to tell you that yet, but you load it into the new system. You check the integrity constraints. We see that there's a few constraints in there. You might build indices to accelerate a little bit the process, but not the same kinds of indices necessarily than the one we've seen. So I'm not going to get too much into the details because that would be too much for an introductory lecture, but they exist, there are indices. You might need to partition across multiple machines. That also, I'm not going into the details. That's big data for engineers. But this is it, extract, transform, load, ETL. And ETL is a verb, so you really say you're ETLing the data from wherever it was to wherever it has to be, right? Who is with me? Right? Very good. Okay, now I'm done with boring stuff always. I'm concluding with the fact that these are the big 3/4. It's like the three musketeers. There's three, but they're actually four. So you know that Oracle, IBM, Microsoft. These are the big three that are known in a relational database management system. What happens? I simplify a bit, right? There were startups created in the 90s, Essbase, Cognos, and so on, that dealt with data cubes. What happened is that the ecosystem consolidated. Oracle bought Essbase, IBM bought Cognos, and so on, right? So the big relational database management systems, they wanted to be part of the story of business and intelligence. And so the market consolidated in this way. So this is why you might hear of Oracle Essbase or IBM Cognos. For Microsoft, it's called Analysis Services, the portion of their database. I actually don't know if they also bought a startup or did it themselves. That I can't remember. But basically, you still have the big three plus SAP, right? SAP HANA. Okay, so if you need just to know who are the players there, then this is basically what you need to remember. And now let's get to the interesting part, the actual technical part, the data model. So I'm going to explain the logical data model. I'm going to say what you can do with that. And then I'm going to explain how it's implemented. Who is ready? Okay. You will see it's not so complicated. Again, the goal is to have high-level data for C-level executives who might not have a computer science background. So it's really meant to be simple to understand. So typically, these systems from the 90s, business intelligence, are based on data cubes. Well, a data cube looks like a cube, except it can have more than 3 dimensions. But because we humans are used to 3 dimensions, I have an example in 3 dimensions. But you have to imagine it could be 4 dimensions, 5, 6, can be more dimensions than that. The idea is that I have dimensions, the year, for example, the product, and the country. And for every combination of this, specific year, specific product, country, for example, the year 24, country, Switzerland, and the product server, I have one value. That value is 7. I have no idea what this means. Maybe this is a quantity or something. Could be a price, could be some profit, and so on. So anyway, there's a value. That's it. That's the data model. I have a cube. It has dimensions. And for every combination of values for each dimension, I store a value there. Every one of these little cubes here corresponds to a different combination of products, years, and countries. So you have to imagine that there's a value in each one of them. For whom is that clear? Right? That's a data cube. That's what it is. So it tells you, let's say, for example, that in the year 2024 in Switzerland, 7 servers were sold. Right? And you have a similar number for every combination. You can see how it's highly structured. Right? Typically, you don't have empty cells in there, right? Typically, every cell has some number, even if it's 0. Okay, so we are good with that. Let me talk about the dimensions. So year, product, country. Here, there's just 3. What do we have as dimensions? Very typically, to give you a few examples. There's the dimension of where. It's very common for a company to have a geographical view. It might be a multinational company in different countries. It could also be a Swiss company looking at the cantons, or maybe the Gemeinden. So typically, there's a dimension of where, right? How many apples or bananas did you sell in Appenzell, in a Roden, or in Baselstadt, and so on, right? So you might have this where dimension. You might have a who dimension. Maybe you're looking at your teams, so the team in Basel, the team in Zurich, the team in Geneva, the team in Ticino, right? So you're looking at your teams. That might be another dimension if you want to compare the sales. You might be also looking at the currency. You have the dollars, the euros, the Swiss francs, so maybe you're also separating your sales by the currency you're using. That might be a dimension too. It might be what? Like the categories of products that you're selling, the phones, the computers, the servers, the fruits, the vegetables, like depending what you're selling, right? So you might also have a dimension for that. The what could also be, as we will see, financial concepts. You could be looking at revenues, at profits, at cash and cash equivalents, equity, liabilities, debt, and so on. So also all of these could qualify as what you're looking at, right? And then there is when. That's the same when as on this slide right here. That's the same when. I told you it's time variance. So what I actually told you there is one of the dimensions is time. Okay, who is still with me? Right? So that's a couple of examples. And this is typically what the dimensions of my cube are going to be. And of course, it depends on the cube, right? The different cube might have different dimensions. But you're assuming that they are there and you have some dimensions. Okay, so then I continue. Now, is anybody here able to visualize in their mind the 4-dimensional hypercube? Some people do that. I tried. It was an obsession in high school. I tried to visualize what does a 4-dimensional hypercube look like. Some people can do that, even in the dimension 5. But it's very difficult. It's very, very difficult. Even this here on a slide that is 2-dimensional projected on the screen, it's actually quite difficult to visualize the 3rd dimension. I mean, I had to do it by projecting somehow. So you can imagine 4, 5, 6, 7, very hard to visualize. So we need some way to still look at the data even when it has more dimensions than that. What we're doing is actually pretty simple. Like little babies, we take all of these cubes, we just collapse that all, and we just pile them up as a single tower, right? So that's what we do right here. So I'm taking it one by one, each one of these cells, I'm just piling them up on top of each other. This is one cell, this is one cell, this is one cell, this is one cell, and so on, one by one on top of each other. And because I changed the way the cells are ordered, I lost the information where they came from, so I need to have it there. So I need to indicate every time where does it come from. So that was the cell for Switzerland 21 Mary, and I'm putting the value there. That was another cell for Switzerland 21 Peter, probably next to this one. That's 7,000. And then I have all of my cells. For whom is that clear? So if that's clear, can anybody tell me what the dimensions of the cube were that gave me this pile of cells? How much by how much by how much? For example, the one I showed you here was 5 by 3 by 4, right? This cube. What about the cube that led to this pile of cells? How much by how much by how much? So it had 3 dimensions, right? Country, year, and salesperson. Value is whatever was inside. Can anybody see that? Yes? 2 by 2 by 2, exactly. You can see that it's 2 by 2 by 2. This one had Germany and Switzerland. This one had 2022 and 2021. And this one had Peter and Mary. Who agrees? 2 by 2 by 2, right? Who visualizes this 2 by 2 by 2 cube with these 8 values, 2 by 2 by 2, these 8 values sitting in the cube, the original one? Who could draw that cube on paper? Right? Most of you. Very good. That's what I want. So now this is for 3 dimensions, and you can imagine for 4, 5, or 6 dimensions, it's very easy. You just have more columns, right? You just add more columns, and then you have higher dimensional cubes. But for us human beings, it's much easier to understand in this way because we see it's 2-dimensional. In here, it's just a 2-dimensional table. It's even a relational table. You recognize a relational table here. It has a name that is called the fact table that corresponds to my cube. Fact table. Remember these 2 words, the fact table. Okay. Now, this was an example, and typically I'm going to get you used to a specific framework that is used in business reporting in many countries all over the world. I'll come back to that. So typically, in that framework, the names of the dimensions, they're called axes. Axis is just a synonym for dimension. The Securities and Exchange Commission calls it this way, so axis, axis, axis. Then the values that you have for the dimensions, they call them member. So Germany is a member of the location axis. 2022 is a member of the period axis. Peter and Mary are members of the salesperson axis, and so on. I added a currency, can also be useful, but here it's all USD, right? It's all dollars. But now you see I have 4 dimensions, right? So axis is currency, and then my value in there. Who is still following? Right? Okay, very good. Now, let's do things on the cubes. You remember that in the case of the relational model, a table had rows and columns. We saw them as sets of maps that fulfill the 3 constraints. What did we do on them? We projected, we selected, we aggregated, we sorted them, and so on, and so on, and so on, right? Well, for cubes, we can do the same thing. So now instead of rows and columns, we have dimensions and cells, right? And the first thing we can do on them is taking a slice. Just like imagine a cake, you're taking a slice of the cake. So taking a slice means you take a specific member in a dimension. In that case, I have a dimension with 4 members, 1, 2, 3, 4, and I'm taking the second one. That's slicing, okay? So imagine that I take a slice on Switzerland, right? That was my fact table. That's my 2 by 2 by 2 cube. If I take the Switzerland slice out of that cube, I end up with a 1 by 2 by 2 cube, right? So it's a square now that I have, a 2 by 2 square. Who sees that? Exactly. That's basically the image I have, that 2 by 2 by 2, and I pick one of the 2 layers, Switzerland. Now, you see that now it's Switzerland everywhere, plus we also have USD everywhere. So what we do typically is we put them above, instead of repeating it on every row, we just put them above in the visualization, in the software that you use for business analytics, and we put them here. These are called slicers. We slice on Switzerland. We also slice on USD, but in fact, USD is all there was, right? But still, it's a slicer. So we say location is a slicer set to Switzerland. Currency is a slicer set to USD. Now I have a period and a salesperson. It's a 2x2 square with my 4 values. Who is still with me? Right. Now, if you give that to the CEO, they are not going to be very happy because they still need, to think about how that all assembles together. No, in fact, what we do is we say we cross-tabulate these 4 things because now, as you notice, we only have 2 dimensions left. 2 dimensions that works on paper, right? Paper is 2-dimensional. So here's what we do. We display it like this, where this period and this salesperson goes on rows and columns. So the salesperson is on the rows, the dimension here, the period goes on the columns. And now I'm actually explicitly showing that 2x2 square to the C-level executives, right? We call that dicing. Dicing means I'm saying period goes to the columns and salesperson goes to the rows. And now I have a very nice grid, 2-dimensional, that I can show to the CEO, right? Who is still with me? Who has heard of the expression slicing and dicing? Never. It's something, sometimes people heard of that. Well, this is slicing and dicing. We basically slice all the way until there's only 2 left. And when there are only 2 left, then we can dice them nicely in this square. So this is what we see here. I'm just displaying it more formally. So this is the same thing, but like you would see it in the official reports. For example, on the website of the Securities and Exchange Commission in the US. This is called the cross-tabulated view. Right, that's what we call it. Who has ever done that in Excel? It's called the pivot table feature. Who has ever done a pivot table in Excel? Right? So I recommend as an exercise that you try. Basically, the way it works in Excel or other spreadsheet software, you fit the facts table, you import it for some CSV or you put it in the cells, you select the whole thing, the whole table, then you go to the menu, I don't remember how it's called, if it's tools, pivot table or something like that. And then Excel is going to just build that for you. You just need to drag and drop stuff. You drag that collocation here, you drag currency here, you have a drop down here, you select Switzerland, you have a drop down, you select USD, you drag salesperson here, you drag period here, and it automatically fills the cells like this. It's magic. So it can do it with a CSV, it can also connect to the data analytics platform of your company that you work from. This is what I say it can take 5 minutes to do, but this is done very commonly by spreadsheet software. So this is a very, very common feature, and I recommend you try it out because that's a good way also to visually make yourself more to get the intuition of everything that I'm explaining, right? So the important part here is that it's really something that is designed for also people without a computer science background, that you can very easily build that kind of views. Who is with me? Right? Okay, so that's the pivot table view or cross-tabulated view that we get with slicing and dicing. So typically, the number of dicers, so the dicers are the dimensions on the rows and columns, right? Typically, you want 2 of them. 2 because that's 2D on a paper. More rarely, you have 1, but then when you have 1, you basically just have a single column. Some people do that. Actually, you do see financial reports where there's a single column sometimes. Right? When you have a balance sheet or an income statement, if you've been in an association, then you've done these financial reports, and then you might have a single column. Then you basically would have a single dicer. You can also have 3 dicers. Now, how do you get that with 3 dicers? Because there's only 2 dimensions to the page. Well, the third dicer, you typically put it as a sheet in your spreadsheets. So you can view in Excel, it looks like it has 2 dimensions. In fact, it has 3. Because the tabs at the bottom, when you change the sheet, they are actually a 3rd dimension. So typically, you could have 3 dicers, but then on your pivot table or on your cross-tabulated view, what you would have in addition is sheets here. You would have tabs, And then you can click, click, click to change the third dimension's value, right? Who is still with me? Right, okay. It's a very visual lecture, right, this one. And the slicer, you can have as many as you want, right? Because they all fit on the top of your view, so you can have many slicers. Okay, so basically, when you drag and drop your dimensions in this way to build a cross-tabulated view, you decide for every dimension, do I want this dimension to be a dicer or do I want this dimension to be a slicer? You basically either put it on top over there or to the rows or to the columns. Okay. Now, another thing. Oh, yes, go ahead.
The slide is always a relational table, while the dice is always a pivot table?
The slice, when you refer to the slice, it's of the cube, right? You have to visualize the cube and you take a slice. This here, the facts table, is only a physical representation of my cube. It's a physical representation of the cube that I, as a human, can better understand, and I can also store that as a CSV file. In fact, it's an implementation of the cube on a physical relational table, right? That's what we are doing here. So this is a relational table, but this relational table is only a representation of the cube. It is not the cube. It's just a representation of the cube. And this here is a third thing. This is the very fancy interactive pivot table that you can work with in Excel. This here is like glasses that you use to visualize and play with the cube. It's a user interface with which you can understand the cube and analyze it, right? So there's the cube, there's the facts tables, and there's the cross tabulation. 3 different things. Okay?
There's another question.
Yeah.
Whether you could repeat the meaning of dicer.
Oh, dice? Dice just is this. Dice means I put a dimension, I drag and drop it in Excel over there, and it's automatically going to make a row for every member, for every value. And I drag and drop my period dimension to the columns here, and it's automatically going to create a column for every possible year in that case. And it's going to put the values nicely at the intersection there. This is dicing. So dicing is really for the dimensions that I put here and here. So that's period axis and salesperson axis that are dicers. Does it make sense?
Yes.
Yeah.
Thank you.
All right. That's where it comes from, slicing and dicing. Okay. Okay, so we've seen slicing and dicing. Let's look at the third one, aggregation. So I don't know if you can actually see that on the side because it looks like nothing is happening, but actually something is happening. I'm basically merging the depth dimension here. These 3 cubes, I'm merging them, I'm merging. So here I only end up with merged cubes. Do you see the difference? Right? I merge like this, these cubes. This is called aggregation. Let me show you on the facts table. Again, that's the physical representation of my cube with 1 cell per row. Imagine that I have this data per country, per period, per salesperson. I want to aggregate that for the whole world. I don't care about the details between Switzerland and Germany. I just want the whole world. Do you see how I do that? Basically, this needs to go with this. It's exactly the same values here and here, except for location, Germany, Switzerland. Then these two, these two, these two. Do you see that? Right? Then since I want to aggregate, I'm going to do the sum. Imagine that these are the sales for Switzerland here, and these are the sales for Germany over there. Then I want 1,000 plus 5,000, which gives me 6,000. And the 6,000 go here. So this, you see now, world is the whole world. It's called domain because this is as high as it gets. I mean, we haven't discovered alien species yet, so that's all there is for the moment. So 1 plus 5. Then 2 plus 6 gives us 8,000. Then 3 plus 7 gives us 10,000. And then 4 plus 8, 12,000. Who understands what's going on in here? Right? I've just aggregated across the location dimension into the whole world. And what I do visually is that since it's always the world anyway, I put it over there in the slicing section. So I have location, now it's the whole world. And in Excel, you can say, it's also a drag and drop somewhere, if you want the sum or the count or the average or the mean or the max, it gives you a choice into how you aggregate. And guess what? It's exactly the same functions as what you use for group by. You remember for group by, the non-grouping keys, we can count, sum, mean, max, average, and so on. Exactly the same ones, right? So I get this. And of course, when you see these 2 dimensions, you get the irresistible urge to cross-tabulate this like it, right? So now you dice with the period in here, the salesperson in there, and you get your nicely cross-tabulated view, right? Is everybody still with me? Right? That also is part of the pivot table feature that you get in a spreadsheet software. Okay. What do I have here? Oh, yes. Something that people also commonly do is they want subtotals and totals. What if we want the total for every salesperson across all periods, or for every period over all salesperson? I add a 3rd row and a 3rd column like this. This is how it could look like. Do you see the totals? So I have 2 subtotals, 22 and 14,000 at the bottom, 2 subtotals, 16 and 20 on the right, and the grand total, 36,000 on the bottom right. Right? So these are called roll-ups. So we'll see later how that all plays, right? But the idea for the totals is that the dimensions are not flat. The dimensions are in fact whole hierarchies. And that's something that's obvious when you look, for example, at geography. You have the whole world, you might have continents, the continents might have countries, the countries like Switzerland might have cantons, the cantons might have Gemeinden, then you can have Kreise and so on, you might even have the districts, Bezirke. So it's basically a whole hierarchy. And when you compute subtotals and totals like this, you're actually having the aggregation at the domain level, right? So here we have the whole domain of all salespeople, and here we have the whole domain of all times, and here the combination of all people, all times. Okay, so that's the idea, right? Period and salesperson in that case are relatively flat, just a list of years and a list of persons. But even for the period, you might have years and then divided in quarters and divided in months and divided in days and so on, right? So also that could have a hierarchy. So the fact that dimensions are hierarchical is also part of the cube, the data cube model. Okay, and in fact, when you have hierarchies like this is what you end up with. Right? So did you see here, when I computed my total on the column, I have this L-shaped header here. The L shape is a very nice way to visualize that it's a total, very intuitive. So if I have more levels, then you see I have Zurich, Geneva, Interlaken, aggregated as a subtotal for Switzerland. Then I have Berlin, Frankfurt with the aggregation for Germany. You see here this L shape. Then the whole of Europe with the total in here. Then Delhi and Beijing here for India, China, aggregation for India, aggregation. I just didn't have enough place on my slides to just put more, but this is it. Then you have Asia here aggregated, and then the whole world with the L shape above everything right there. For whom is that intuitive, the L shapes? Right? So this is how you get your totals on the column side. You visualize the hierarchy of the dimension. Now for the rows, you could, okay, some people might use L shapes, but for the rows, that's not what's typically done. For the rows, you have to think of how accountants do that. When the accountants do their balance sheet, income statement, cash flow statement, statement of change in equity, and so on, they don't do L shapes there. What they do instead is that they use underline, bold, indentation, and so on. That's more typical. So you see, you indent Zurich, Geneva, Interlaken, then Switzerland has a bit less indent than Berlin, Frankfurt. Then you add some horizontal lines. Then you might have a double underline, in the middle and put it in bold to basically emphasize that it's a higher level. And then you even increase the font and even put a different background color here with an underline above and below, and then you make it apparent. So it's only visual, right? In the columns, we like to use L shapes. On the rows, we prefer to use indentation, but it just does pretty much the same thing. By the way, this and this is the same data. It's just that I swapped the rows and the columns. That's all I did here. right? And so instead of the L shapes, I have the indentation. Everybody still with me, right? So who has ever seen a balance sheet or an income statement or that kind of things, maybe in an association, right? So this is exactly for financial statements, what's very typical. Okay, now here's the cool thing, the very cool thing that happens visually with that kind of views. It's very interactive. Imagine that I'm not interested at the city level. I'm only interested in the country level. So I can just pressing a button there. Maybe I'm too far. Oh, there, yeah. You see, the cities are gone. I just made it disappear from the view. What if I don't even want the countries? I just want the continent. Click. Now I just have directly the continent. And if I only care about the whole world, then there you go, the whole world. I can even put it over there because there's only one left. That is an example, by the way, of cross-tabulation with only one dicer. Because now I'm left with only salesperson on the rows. And on the columns, I have nothing. It's just a single column. What you've seen here, tack, 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 that's called a roll-up. You're rolling up just like curtains that you roll up. And that's called, that's called drill down. Drill down, drill down, drill down. When you go further into the details. Roll up, drill down, roll up. Okay, who is with me? Right, so it's very convenient. You see, to analyze the data, you can select the granularity of the data that you want to analyze. Any questions so far? Right, you're doing well. And who understands what I'm saying? Right, very good. So this is all very visual. So this is what people see when they use the pivot table or when they use these very fancy user interfaces for the data, the business intelligence software, so S-Base, Cognos, and so on.
I have a question on Zoom. Yep. Is a rollup a combination of aggregations?
Yes.
Is a rollup a combination of aggregations?
Rollup is the action of clicking to remove from view the lower ones and drill down doing the opposite. Physically, the aggregation is needed to compute what you put in there. This is aggregated from here. You aggregate this from here. You aggregate this from here and here. You aggregate this from here and here, and you aggregate this from here and here. So the aggregation would be a necessary thing that you need to do in order to display these views and to be able to roll up and so on. And the reason is, in your original cube, you might only have the blue data. You might only have this, and this, and this. And the other values are computed on the fly by the software, right? And that's done with aggregation, all right?
Follow-up, drill down is adding granularity and roll-up is the reverse of it.
Yes, they are the reverse of each other. So roll up, it's like a curtain, right? Imagine that's like a curtain. I'm rolling up the curtain and I'm drilling down, right? Okay, there's a word, when you do that, I heard it once in a train, it's Aberklappe in Swiss German, like, all right. So roll up and so on, that's what it is. Does it make sense? Yeah, let me see how much time I have left. Okay, have a few minutes left. So now let's move to the physical part. How do we implement that? Well, what's really nice is that I spent a semester telling you about relational database management systems and SQL. It turns out that we can implement data cubes and these things on top of SQL. So that's very nice because now we can apply everything we've seen to this. And by the way, that is the reason why IBM, Microsoft, and Oracle purchased these companies, because they were SQL relational database systems makers, and they saw that there's a synergy here because you can use these systems. So on a high level, what I just described is rollup, relational OLAP. That's the one we are going to see. There's other systems called MOLAP, which are completely different. I'm not going to talk about them. It's just a different implementation, MOLAP, that is not on top of SQL or relational tables. It's just totally different. So I'm just focusing on rollup, which is the implementations of data cubes on top of tables. Now I have super good news for you, because we saw the normal forms, right? The first normal form, the bus code normal form, and I told you very quickly the second, third normal forms, which are not material. turns out we can go all the way to the 6th normal form. And in fact, the 6th normal form is the easiest ever to explain because this here is in the 6th normal form. In fact, a fact table is in the 6th normal form. How do I see that? It's basically that I have dimensions, 1, 2, 3, 4, 5. I have all possible combinations of the dimensions, all the cells of my cubes, and that's a primary key, all the dimensions together. And value on its own, just one more column, that's standing there on the right. This is the 6th normal form. That's why I'm saying it's the most structured thing you can have ever. That's a data cube, right? That's why I put this very happy cat on the slide because that's it's just mathematically it's beautiful, right? So that's a cube. So now you can associate the 6th normal form with this way to visualize a data cube like this. Okay, everybody with me, right? I'm not going to define it formally in the 6th normal form. I just want to show you like this is what it looks like. But there are people who don't like the 6th normal form and they would like to have multiple columns on the right. For example, they might want to have the profits, the revenues, and so on. So they might have multiple columns here that they want. That's not a problem though, because you can go from one to the other quite easily, and that's called pivoting. That's why, by the way, it's called pivot table. And maybe you can just look at the slides to understand what's going on. Because what you do to go back and forth between the two, imagine that you have this, which is in the 5th, but not in the 6th normal form, because it has multiple columns left here. What I can do is take this revenue and profit, and I can turn that into the members of a new dimension, members that I put here, so revenue and profit. And now I just reshape, it's like the reshape in pandas, right? I have 2 by 4, that becomes 1 by 8. So that's just a reshape of the table where these column headers become values in that new column that I call a measure. Who is with me? Right? Okay. But the reason I'm saying that is that I'm not going to work with this. So with this, I'm always going to work with a single value column in the 6th normal form. Okay. Now, because we love normal forms so much, the dimensions that we have might have some more data. For example, the dimension might be a date, and it's associated with a year, a month, and so on. But because it needs to be in normal form, we need to offload that to other tables, which we call satellite tables. So the dimensions that you have in your 6th normal form table, the facts table, are actually foreign keys pointing to other tables, right? And now there are people who love normal form so much that they even want the satellite tables to be in normal form, and then you get what's called a snowflake schema, right? Where even denormalize, you remember what? When you normalize and put in higher normal forms, you keep decomposing into more and more tables. Has anybody heard of the Snowflake company? Databricks, you've heard? Snowflake. These are 2 of the major database companies at the moment. And so there's a company called Snowflake exactly for that reason, right? Because of this Snowflake schema.
A quick confirmation. So someone's asking whether the 6th normal form means having only one value column with all the dimension columns.
Yes. Of course, it's not a formal way of saying that, but yes, absolutely. The 6th normal form means you have only one column that's not a primary key, right? And it also means that the primary key has all possible combinations of the columns. So there's no sparsity, it's the whole cube, right? Okay, so that would not be the 6th normal form because there's 3 columns on the right. Okay, awesome. And so just to show you an example of the Snowflake thing, you might have a facts table that just contains the Gemeinde or some key for the Gemeinde. Then you offload the country information to another table, and you offload the country and the continent to yet another table. And then you have a nice normalized high normal form view. Who is with me? Right? Okay. Some people who do not like the 6th normal form prefer to take the satellite tables and join everything. And then what you end up with is even more columns in there where you just squeeze the columns coming from there into the table in there. In fact, Excel loves that because you can also import these denormalized fact tables in Excel where you put the satellite information in there. Excel can do that too. It's absolutely able to do these things. And you end up with something like this, right? Europe, Switzerland, and so on. By the way, do you see that this is not in the Boyce code normal form? When you do that, it's denormalized. because you see there's a functional dependency from country to continent and from city to country. Who sees that? Right? So this is why this is not in the high normal form. This is denormalized. It's just in the first normal form. Right? Okay. All right. But I'm not going to work with this. I'm going next week, of course, to just work with these ones, the 6 normal forms. So I'm going to end on that slide and finish next week. Next week will be the final lecture. I'm just going to finish that. Then we have a quiz. So you should come. The winner gets a prize, and it's easier to hand over the prize in the lecture hall than over Zoom. So we'll have a final lecture next week, and then there will be no lecture in December. So try to come, if you're on Zoom right now, try to come in presence next week. It will be fun to celebrate the end of the semester. Thank you very much. Enjoy your meal. Enjoy the exercise sessions. Thank you, Martin, for moderating, and see you next week.